And welcome back for part 2. So what we're going to be working on today is talking about, we worked on sine, cosine, tangent. But now what happens if I don't want to find a side, and I don't know an angle, but I do have sides? Can I go backwards? The correct answer is yes, you can go backwards. And we call them inverse sine, inverse cosine, and inverse tangent. The important part that you need to know about this is how they are denoted on your calculator. For instance, inverse sine, if you want to put an arrow out, looks like this on your calculator. Sine inverse of x. Inverse cosine, guess what? Looks like this. That's inverse cosine of x. It is not cosine to the -1. When you see this, you need to say inverse cosine. And finally, inverse tangent is denoted like this, inverse tangent. All right. So now that we have that down, let's talk about how do we actually use these things. So it says here, use trigonomic ratios, functions, to define the measure of theta, round to the nearest degree. So when they ask you to find the measure of theta, this is your key point here to know that, hey, I need to use inverse trig because I need to find the measure of theta. And then what I do is when I take a look at the picture that they give me, I gotta go, all right, well, let's do the same things. Let's label my hypotenuse, my adjacent, my opposite. So I look at my triangle. Well, that's easy enough. There's my hypotenuse. It's across from the 90-degree angle. My adjacent, oh, that's this one over here because it is the one that's attached to theta but not the hypotenuse. And my opposite is either what's left over or across from the theta. There's my OPP. So now I go over here and I gotta go, I need to figure out, again, which trig function, sine, cosine, or tangent, uses opposite over hypotenuse. Opposite over hypotenuse. Well, that's going to be, normally you would go up there and take a look, hey, sine of x equals opposite over hypotenuse. Okay? But I don't know what x is or theta is anymore, so I need to find that out. So that's when I know, oh, I need to use inverse sine of theta. And instead of inverse sine of theta, what I input is the opposite over the hypotenuse, and that will get me my theta. All right, so what is opposite over hypotenuse? So I put this in my calculator, sine inverse of 12 over 15.7. So we need to go get our handy dandy calculator, which we will here right about now. So again, here's my calculator, and I'm hit the mode button to make sure, yes, I am still in degrees. All right, so then I'm going to go in here, and where is inverse sine? Inverse sine is right above sine. So the way I do that is I'm going to quit here, so I can quit. And I'm going to go second sine, it gets me my inverse sine, and I do 12 divided by 15.7, parentheses, enter. And it tells me it's 49.847 degrees. So I come in here and I say that that is 49.847 degrees. That's it. That's all you have to do. All right. So now I have an example for you to do. And I want to see that you can do it. So I hit that. Here it is. Your turn. Again, if you're watching on YouTube, you need to pause me here. Otherwise, see you if you get the right answer now. Bam, there's your answer. Hopefully you got the right answer. We'll find out. If you have any questions, that's what tomorrow is for. Let's go take a look. What's next? All right, so now we get something, real-world problems. And real-world problems are not always as nice. And so what we have to figure out here is what's going on. All right, so it says here, a person on an airplane looks down. Hey, you're right up here. Started drawing. Here you are, you're riding an airplane. Woohoo! All right, you look down. Okay, and an angle of depression. What is an angle of depression? Angle of depression is this. Here I am up in the airplane looking out, and if I were to look straight, there's that straight line right there. That's me looking straight backwards. It's really hard to do in an airplane. But then when you look down, I'm going to look down here. The looking down part, so here I am looking straight, now I'm looking down 15 degrees. Okay, this is my line drawing straight down from where I was sitting and looking down. So when I go look straight across and I look straight down, this whole angle will be 90 degrees. My angle of depression being 15 means that I have 75 degrees left over. Ooh, I wonder if I can use that. It says here the plane is flying at 10,000 feet. There's my 10,000 feet. That's a really low flying plane, by the way. Normally at cruising altitude, you're at 35,000 feet. How far is the person from the point on the ground to the nearest foot? So I want to find this distance right here. I want to find out, there's the point I'm looking on the ground. So look, so the first question you ask, am I looking for a side or am I looking for an angle? You're looking for a side. Okay, great. So since I'm looking for a side, I know I'm using sine, cosine, tangent. All right, so I got to take a look at what's given to me. I'm going to go a little bit quicker here. So 75, that's degree. That means that's the opposite. This means this is my hypotenuse across from that 90-degree angle. And this over here is my adjacent. All right, and I know my adjacent. I want to know my hypotenuse. So adjacent and the hypotenuse, that's cosine. So I'm going to want cosine 75 degrees is equal to my hypotenuse, my adjacent over my hypotenuse, 10,000 over my hypotenuse. Ooh, so again, this is another one where I'm going to have to do that little cross multiply fun trick. Okay, put that over 1. 10,000 is equal to cosine of 75 degrees times x. Divide by cosine of 75. Cosine of 75 degrees is equal to x. I get my handy dandy calculator, and it's going to say 38,637.033 feet. But they want it to the nearest foot, so it's just going to be 38,637 feet. All right, and we're going to go ahead and see what's next. All right, sightseeing. The sightseer is on vacation, looks down into a deep canyon. So again, here I am. I'm a little sightseer. Woo! I'm up here on a canyon. I'm looking down. I see a river way down here. Okay, the angles of depression to the far bank. Again, angles of depression. So what does that mean? I have this straight down line here. Let's get a better color so you can see it better. I have this straight down line here. That's where I'm standing. I make a straight line right here. This is me looking straight. All right, pretend I'm on my belly looking down. All right, that forms a 90-degree angle. All right, so. Okay, so it says the angle of the depression to the angle of depression to the far bank to the near bank river are 61 and 63 degrees. Oh, so if I go to the far bank here and I look down, it's 61 degrees. But if I look here, the nearest part of the river, it's 63 degrees is my angle to depression. Okay, if the canyon is 1,250 feet deep, that's the deepness here. How wide is the river? This is a tricky problem. Okay, and what people are probably saying is, look, mister, it's just 2 degrees. We can use that, 2 degrees. Not so much. You got to pull this apart to 2 separate triangles. Okay, and I'm going to draw these 2 separate triangles out. So the first one I'm going to draw is the one with the river. Okay, here. There's my river. All right. They told me that my angle of depression for that one, going with it, is 61 degrees, which makes this 29 degrees. Okay. Then they had one without the river. Okay. And here's my second picture. And the near bank of the river. So here's my river again. But this time they did it here. And this one was 63 degrees. Okay. Which makes this one 27 degrees. So what you can see is I got two triangles. This one here, I'm going to label this X. And this one is X plus my river. So if I find out what this X is, and I find out what X plus a river is, and I take away whatever this is from this, I'll have it. So this is really doing two problems at once. Okay, and again, I know this is 1250. 1250. They're looking for a side on both problems. So you pick which problem you want to do first. Let's do X first. I want to find X. Makes life easier. So I go and say, again, find out, here's my angle theta. I'm looking for a side that is opposite it. So, and I have an adjacent. I do not have the hypotenuse. So I have tangent of 27 degrees is equal to opposite of X over adjacent of 1250. I go ahead and get my handy dandy calculator out, and my answer for that one is, so after multiplying, getting 1250 times tangent of 27 degrees, I get 636 feet, 0.906 feet. All right. So then I got to go do the other one. Oh, how do I go do that other one? Well, let's pick another color. Let's go plain old black. So I need to find out the X plus a river. All right. So again, that is equal to X. So my X plus a river, same deal. It's going to be tangent, this time of 29 degrees, is equal to X plus a river over 1250 degrees, or 1250 feet. Again, this time I do 1250 tangent, 29 degrees, and I get an answer of, all right, so is 692.886 feet, and that's again equal to X plus the river. So all I have to do is I got X plus the river. Let's go ahead and subtract. All right, so I'm going to go ahead and subtract the two, and I get an answer of, so when I do that, I get 55.979 feet. Hey, that's the bell. That means it's time to go. And that's the end of that. So again, the big thing on this one here is that the river, that you had to draw two triangles and see the difference between the two, and see that the river is what separated the two, and you had to do both. Okay. Whew. All right. I hope that helps. One last thing I do need to do is show you about this chart down here that comes up next. This chart, you need to know these. Okay. The best way I can say this is look at this. These are the ones I want you to know. All right. Cosecant, secant. Cosecant, remember it was, instead of being opposite over hypotenuse, it was hypotenuse over opposite. And secant, instead of being adjacent over hypotenuse, it was hypotenuse over adjacent. That's why they're reciprocals. This is just showing that they are reciprocals of each other. This one's also kind of interesting, and you should know a lot. This one down here, tangent is sine over cosine. Know this. Know this. That's a biggie. Okay? All right. We'll see you tomorrow. Good luck. God bless. And